Hello, this is Ms. DB, and in this video we are going to review some of the problems on the Chapter 5, Section 5 worksheet on indirect proof and inequalities in one triangle. So you should first read through pages 332 and 335 and make sure you get a good idea of what this assignment is about before watching this video. So we've already been working a lot with direct proof. That's what we've been doing since chapter 2, is we prove things directly. We start with a true hypothesis and prove that a conclusion is true. So in an indirect proof, we start differently. We assume that the conclusion is false. That is, that the opposite of the conclusion is true. So then we show that this assumption leads to a contradiction. For example, two acute angles do not form a linear pair. That's our statement. So to write an indirect proof, first of all, we try to identify the conjecture to be proven. So here's our example. We could say that angle 1 and angle 2 are acute angles. So we assume that that's true because the statement said two acute angles do not form a linear pair. And we want to prove that those two angles do not form a linear pair. So assume that the opposite of the conclusion is true. So the opposite of that would be that angle 1 and angle 2 do form a linear pair. That's what we assume. The opposite of this, what we want to prove, assume that's true. All right, now we're going to use direct reasoning, proofs, theorems, postulates, etc., that the assumption leads to a contradiction. All right, so we know the definition of a linear pair is that the two angles, the measure of the two angles would equal 180. So that's a true thing. We use that. That means that also, because we already said that they're acute angles, we know that both of those measures are less than 90. So measure of angle 1 has to be less than 90, and measure of angle 2 has to be less than 90. If you take a measure less than 90 and add it to a measure less than 90, you must get something that is less than 180. There's no way to equal 180 if both of their measures are less than 90. So this is our contradiction. When you get a contradiction, when you get something that can't be true, then we can do the last step, which is to conclude that the assumption is false. Our assumption right here, step 2, that these two angles form a linear pair. Therefore, the original conjecture must be true, that angle 1 and angle 2 do not form a linear pair. All right, we're going to do that for this problem. So our conjecture to be proven is right here. That is what we want to prove. An obtuse triangle cannot have a right angle. So what is the opposite of the conclusion? The conclusion is that it cannot have a right angle. The opposite of that would be it can have a right angle. So the opposite would be an obtuse triangle can have a right angle. All right, so direct reasoning to arrive at a contradiction. If an obtuse triangle can have a right angle, well, we know the triangle sum theorem says that in this triangle, measure of angle A plus measure of angle B plus measure of angle C has to equal 180 degrees. That's the triangle sum theorem. Triangle sum theorem. Okay, so we know that angle B is the obtuse angle up there. So measure of angle B has to be greater than 90 degrees. So let's see. I'm going to write that. Measure of angle B is greater than 90 degrees. And that's because of the definition of obtuse. Okay, that's true. Also, one of the other angles has to be a right angle. So we call it angle A. It doesn't look like a right angle, but we'll say that that's the one that's equal to 90 degrees by the definition of right angles. So if we put those together into the triangle sum theorem, the measure of angle A is 90 degrees. the measure of angle B is something greater than 90 degrees, plus greater than 90, plus the measure of angle C, which we don't even know yet, has to be equal to 180. But if we have 90 plus greater than 90, so 91 even, that's already more than 180 degrees. So all of this is actually going to be equal to 180. I mean, it's not going to be possible to equal to 180. It's going to be greater than 180. So this is a contradiction because it's not possible to have the three angles in a triangle add up to more than 180 degrees. So this is a contradiction. So therefore, the conclusion is false, which was the obtuse angle can have a right angle. This is false, which means that this is true, that our original conclusion is true. And I think there might have been a step 4 where I was supposed to write that. I'll write it down here again. The statement, an obtuse triangle cannot have a right angle, is true. So there I go. All right, so you're going to do the same thing for this problem. It says that the sum of the angle measures of a triangle cannot be greater than 180 degrees. And we're going to do that by using the exterior angle theorem and the linear pair theorem. So the exterior angle theorem says that angle 4 would be equal to angle 1 and 2. And the linear pair theorem says something like angle 3 plus angle 4 equals 180. So first we're going to assume the opposite is true. So you're going to assume that the measures of a triangle can equal greater than 180. So I'll just say greater than 180. We're assuming the opposite is true. Okay, angle 4 is an exterior angle of the triangle. That's already given. It's in the picture. The exterior angle theorem says that measure of angle 4, that's this part here, is equal to measure of angle 1 and measure of angle 2. So put those in here. Also, from this picture, we can see that angle 3 and 4 form a straight line. So you're going to put 3 and 4 in here. That means that angle 3 plus the measure of angle 4 equals 180. So we'll have 3 here, we'll have 4 here, and then we're supposed to combine steps 3 and 4. Well, maybe we should put this in here. 1 and 2. Okay, so measure of angle 1 plus measure of angle 2 equals measure of angle 4. Also, we know that measure of angle 3 plus measure of angle 4 equals 180 degrees. So we want to combine some stuff here. We know that measure of angle 4 is equal to the measure of angle 1 plus measure of angle 2. So I'm replacing measure of angle 4 with what it's equal to. And it's equal to this. That's the same as the measure of angle 4, because we wrote that measure of angle 1 plus measure of angle 2 is equal to measure of angle 4. So then you can replace, we'll leave the 3 here from number 5, just put that back in, but measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So we just wrote that measure of angle 3 plus measure of angle 1 plus measure of angle 2 is equal to 180. But we were supposed to try to find that the measures of the triangle can be greater than 180. And we found that they're equal to 180. They can't be both greater than and equal to 180. Therefore, that last step is a contradiction to what we were assuming. So then the assumption is false, and the sum of the angle measures of a triangle cannot add to more than 180 degrees. So if your assumption is false, then you can show that your original conclusion is true. All right, then we're going to move on to something else. This is looking at inequalities in one triangle. So if you have a triangle, if two sides of the triangle are not congruent, then the larger angle is opposite the longer side. So in this triangle here, we don't have any congruent sides, and we can see that this angle B is bigger than the other angles. So this angle B is going to be opposite the longest side. The largest angle is opposite the longest side. So measure of angle C is greater than the measure of angle A because of the side lengths. In this side we have AB is given as longer than BC. So therefore the angles opposite are larger. They line up with each other. In the next one here we have if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So it works both ways. The larger angle is opposite the larger side, and the larger side is opposite the larger angle. Let's look at this one. It says write the angles of triangle DEF in order from the smallest to the greatest. So find the largest side. That's this one. So angle E is opposite that side. That's the largest angle. They want us to go from smallest to largest, so find the smallest side. Here's the smallest side. It's opposite the smallest angle. So angle F would be the smallest angle. And then find the next smallest side, that would the medium side, that would be 2 for FE. It's opposite angle D. So when I say opposite, when you say opposite, that's the side that's not touching it. So this side here, get my pen to work, side DE is opposite, oh, you didn't draw. Should be drawing, and it's not. All right, well, you can see that side DE is opposite side F, and side FE is opposite side D, and so on. So angle F is the smallest, and then you would say angle D, and then you would say angle E. And you do the same thing for number 8 and for just number 8. All right, next we're going to look at what's possible to have a triangle. What do the side lengths have to do? A triangle is formed by 3 segments, but not every set of 3 segments can be a triangle. So this one works, 4, 4, and 7. But 3, 3, and 7 don't work. They wouldn't connect. These two sides would not connect. So what happens is that you have to have this true, this triangle inequality theorem. Any two sides of the triangle has to be greater than the other side. So you add AB plus BC, it will be greater than AC. And you add AC plus CB, it will be greater than AB. Any two sides have to be added together, have to be greater than the third side. So you're going to do that with some triangles. And when you do that, there's kind of a lot to check. So for the first one, I wrote out what you're going to be checking to see if it's a triangle. So let's do number 11 because it looks a little trickier. It says that x equals 4, and then these are the sides of the triangle, 3x plus 2, x squared, and 2x. So to check if we can possibly have a triangle, we need to substitute the 4 back into each of those sides and get numbers. So the first side would be 3 times 4 plus 2, and the next side would be 4 squared, and the next side would be 2 times 4. So we simplify that. 3 times 4 is 12, plus 2 is 14, 16 for 4 squared, and 2 times 4 is 8. Here's our 3 sides. We have to check all the combinations. We have to make sure that 14 plus 16 is greater than the third side. We have to check that the next side would be, let's do 16 plus 8 has to be greater than the third side, which would be 14. And we also have to check that 14 plus 8 has to be greater than 16. So we want to see if each of these are true. 14 plus 16 is 30. 30 is greater than 8, so that one's true. 16 plus 8 is 24. 24 is greater than 14, so this side is true. And 14 plus 8 is definitely greater than 16. So all of these work, so this can be a triangle. If you got any no's, then you would say this cannot be a triangle. And there are some problems where you will get a no when you check your 3 different measurements. If you get any no for any of those, then this cannot be a triangle. All right, and then finally we're going to find the possible range you could have for a triangle if you are given 2 sides. And there's 3 different things that we'll have to check, just like the 3 things we checked to see if the 3 given sides could be a triangle. So in this example, we are asked to see what could the possible lengths of the third side be if we know one side is 6 centimeters and the other side is 11 centimeters. So we write 3 inequalities and solve them. So we do all 3 possible things. We take the missing side plus 6, that has to be greater than 11. The missing side plus 11 has to be greater than 6. And then the 2 given sides have to be greater than the missing side. So we solve this, subtract 6, s has to be greater than 5. When we subtract 11 from both sides on the second inequality, we get s is greater than negative 5. And then we get that 17 is greater than s. 17 greater than s is the same as s is less than 17. You could write it either way. I'm going to write it that way so it helps me in a minute. Now look at these first 2. The first 2 tell us that s has to be greater than 5 and s has to be greater than negative 5. Well, you know on a number line that 5 is farther to the right than negative 5. So that's if s has to be both of these, then s greater than 5 would sum that up. It has to be both. So we're just going to use the s is greater than 5 part. We're not going to use the other part. So when we say that s is greater than 5, that means then, right here, that another way of saying that is right here, that 5 is less than s. And we also already knew that s has to be less than 17. Oh, here, it moved over here. So s is less than 17. So we can combine these to say that s has to be between 5 and 17. So here's the smaller range, and here's the greater range. So s is going to be between those in words. All right, so number 13, I've got the 3 inequalities set up for you. You just have to solve each of these. And then for the first 2, you'll have to decide, like if you have a 5 and if you have s is greater than negative 5 and s is greater than 5, then you have to use the more limiting one. So s is greater than 5. And then this one will be your upper range. And then you put them together in an inequality. And you're going to do the same thing for 14 and 15, where you'll find the range. So it's going to look very similar. What you do for 14 and 15 is going to look very similar to number 13. I just didn't write all the steps for you. So we're going to call the missing side s. I know that s plus 298 has to be greater than 177. I also know that s plus 177 has to be greater than 298. So those are the 2 that will determine your lower range. And then I know that the missing side, so I'll put the 2 sides I know, 177 plus 298 is going to be greater than the missing side. And that will give me my upper range. And then you'll put it together with your lower range is less than s is less than, and then you put your upper number in here. And then you do the same thing for number 15. And that's it. Let me know if you get stuck in anything, and have a wonderful day.